Not quite. That's okay. People are trickling in.
Yeah.
Hello, everybody. Those lights are really bright. They're really, really bright. We're here to talk about something that doesn't work yet. So there might be some imagination required during certain parts of this talk. No, it's all going to work just fine. So with David, Damian, Microsoft, ASP.NET, blah, blah, blah. We've spoken to probably many of you and lots of people at NDC over the past few years about SignalR, something very fond to both of our hearts. We haven't had a chance to work on it for a while. We've been busy shipping ASP.NET Core. But we're back working on SignalR again, or at least some people are. And so we're here to talk to you about the plans for SignalR in the world of ASP.NET Core. And we're going to look quite a lot at the underpinnings of this new SignalR world, something that we've currently called ASP.NET Core sockets. You can throw all of your abuse at us around how we're terrible at naming, but that's what it's called right now, ASP.NET Core sockets. So let's dive right in. And I will warn right out front, as I said, it is super, super early. Like, a lot of this stuff is incredibly aspirational, all right? So everything you're seeing here probably will change. Some of it, I mean, the concepts hopefully will stick around, but some things here might change over the coming months. So SignalR as it is, right? We all know what SignalR is. Real-time web framework for ASP.NET. C# client, C++ client as of a couple of years ago. JavaScript client, Java client, which isn't particularly good, but it's there. And it's a great way of building real-time application, real-time functionality into your application. When we set out to build the new SignalR, the one in ASP.NET Core, we learnt a lot over building two major versions of SignalR. And there were some things that, given our time, again, we would choose not to do this time. And so we have an opportunity now to kind of start afresh with new eyes, with a whole bunch of years behind us after having built the last SignalR. So there's a few things that you're not going to see next time. We no more jQuery dependency, which people have been very vocally having their opinions on GitHub for a while. We're starting out with no jQuery this time, so there will be a new JavaScript client. No more auto reconnect with message replay. This was one of the things that SignalR did for you before, where if a connection was made to the server and then for whatever reason the connection dropped, like the physical underlying connection dropped, the client would attempt to reconnect underneath the same logical connection from your point of view and try to make that look seamless to you and the client. And that required a lot of gymnastics on the server. We had to store messages that were otherwise would have been sent to that client that weren't being sent right now. And it really forced SignalR to do a lot of things that you would more typically associate with a durable messaging platform than with just a real-time messaging platform. And while it worked okay, it really did complicate the design of SignalR on the server. And it was, frankly, a bug farm. There were a lot of issues in supporting this reconnect problem. It also led to issues of memory use, and people wouldn't quite understand why there was so much memory being used in the server. It was because we have to store these messages for clients that are in this phase of reconnecting. Those things were configurable, but it was just an area that we felt when we looked at people's code and how they were using it, it just wasn't necessary for us to do it in the framework. You're better off leaving concerns like, do I want messages to be able to be stored for particular clients and then replayed on Connect as an application concern. And then if we make the framework more flexible, composed of better pieces, you can plug that logic in yourself. So that's not going to happen by default. It will still happen for one particular transport. The long polling transport, you have to do it for. But that will very specifically be done just for that transport rather than being a core part of SignalR, which it was in the beginning. No more hub state. We had a feature, it wasn't really used much from what we saw, which basically enabled you to have the client and the server both party on a shared state bag, in C# on the server and JavaScript or C# in the client, and it would get round-tripped anytime the state changed between any message going through client and server. It was a bit messy, it wasn't a particularly nice a thing for us to support, and because not many people used it, we're just not going to do it this time around. Unless lots of people scream at us and they come out of the woodwork and say, we really want hub state, then we can look at bringing something back. No more multi-hub endpoints. So previously in SignalR, you would create a series of hubs, you might have more than one, and then you would connect to the hub endpoint on the server, and all your hub traffic would go over that endpoint by default. Now, that seemed like a good idea at the time, but the reality is that confused almost everybody. And everyone would always use terminology like, I'm connecting my clients to this hub. In reality, you were never connecting clients to a specific hub. You were just connecting clients. And we did all the work of trying to figure out what hub, routing all the hub traffic over that single connection. It meant we had to multiplex multiple hubs over one connection, which meant we needed a complex sort of payload type, an envelope that knew the hub, blah, 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 blah. It made things complicated. And it didn't really give us much benefit. And so in the new world, when you create endpoint, when you create hubs, you get a specific URL per hub, basically, right? Nice and easy. No more single scale-out models. So we had this one thing in the old SignalR, which was message bus, and it was the root of the world. And if you ran in memory, you had an in-memory message bus. And then we had these pluggable scale-out providers, which kind of replaced or augmented the one true message bus. And all messages for SignalR in a little SignalR world were routed through this one message bus. And that's really because we started out designing SignalR for long polling. Right in the beginning, everything was designed around how long polling worked, because WebSockets didn't exist when we started with SignalR. And that's also the same reason why we did auto reconnect previously, was because you needed it for long polling. But again, over time, the single model scale out causes issues. The way that we do it in SignalR today doesn't scale particularly well. It only scales well for certain payload types. So if you're building a system where you just send out broadcasts to all the connected clients and you're in control on the server side of when that happens, it scales pretty well, okay? Assuming you're only doing a message every few seconds, or you control the payload size, that's fine. As soon as you start building something more collaborative, where you have clients sending messages to each other, or they're in control of what's going on, that just doesn't work, okay? Because you can't control the rate of messages going through the message bus. And if you've got lots of different people trying to send messages at the same time, the way we did it is that you have lots and lots of servers scaling out your traffic. They all share a message bus, and every message to any server, to any client, goes over to every single server. So you can't, for example, have all the really busy people on one server and all the not so busy people on another server. SignalR didn't know. It just sent messages to every single server. So you would get to a point where that just wouldn't scale. And if you wanted to do anything else, you had to throw all that away and just do something completely custom, which was not great.
Yeah, we had some teams in Microsoft build systems where it kind of took the entire server down because they had the built-in scale on the cloud. We had one team take down an entire Azure stamp by having our built-in scale by by default. We kind of said, that is kind of the nice solution. And if you have scale that is very specific to your workload, you have to kind of have your own logic to understand which things should go onto which servers, and then things scale better that way.
Yeah, and so they redesigned their stuff with our help, and now they have a very nice scalable system that works in Azure well. But yeah, so we don't have like one out of the box that works around this simple scale-out model that we expect everyone to do. We have a totally new model, and we'll show you an example of this later, which is much more pluggable. And we'll ship one based on Redis, and we'll show you the different strategies. But we think this is going to set us up for a much better sort of scale point in the future. And the last thing is no support for multi-server ping pong. So when you have a scale-out scenario and you've got clients that might be connected to one server for one part of the connection, but when they send the next message, they ping pong to a different server because they're being load balanced. In the old world, that would work because all the servers were sharing a single message bus, and we maintained sort of enough state, or we would recreate state on the new servers when you ping pong from one to the other. Doesn't work in the new world. We require by default that you have to have sticky sessions enabled when doing scale out. It turns out not to be too much of a problem in the real world from what we've seen so far. And the reality is, if you did want to enable ping pong, you could write code to do that yourself anyway. The new system is fairly flexible, and so you could get in there and rehydrate things if you wanted to and make that work again. But out of the box, it's going to require you to have sticky sessions. All right, so that's all the bad news. The stuff that changed. It's not really bad news. The things that are going to change. Different things. Here's all the new stuff that people have wanted for a long time that we're actually going to do this time. So binary data support is coming, and we have support for that already, I think, actually. So you'll be able to send and receive binary data. It'll be host agnostic, so you'll now be able to run SignalR. The SignalR infrastructure, or the ASP.NET Sockets infrastructure, isn't really tied to isn't tied to HTTP. The programming model that you use, hubs, endpoints, they don't talk HTTP. They just deal with connections, okay? And you can host those on whatever you like. And I'll show you an architecture diagram in a minute that might make that a little clearer. That will enable us to do things like, connect TCP clients to SignalR, okay? Which is really nice. That's something people have wanted for a long time. This low-level API under hubs, we've ripped out the persistent connection API. That was what we had in the old SignalR. That was tied to HTTP. We have a new API called Endpoints, okay? And we'll show you some examples of endpoints. Endpoints are very, very flexible, and they're now the building block of essentially what will become all non-HTTP workloads that run on ASP.NET Core, which is something that we aspire to do by the end of the year. We'll use this Endpoints API that we're starting out with in SignalR. Supporting multiple protocols and formats. So today, SignalR basically just speaks JSON, right? If you have SignalR, it's always text and it's always JSON, and we own the shape of the messages. In the new world, that's going to be a lot more pluggable. So if you're at the endpoint level, you can do whatever you like, right? You can send protobuf, you can send JSON, you can send custom protocols, and your endpoint code can look the same no matter what type of connection is currently connected to it. So you can literally have different connections from different clients that speak different languages all go through to the same endpoint, which is kind of nice. You have to write code to do it, but out of the box you can get that. And for something like hubs, we will most likely ship both a JSON and a protobuf version of hubs out of the box, and you'll be able to have a single hub with multiple different clients talking to it, speaking either JSON or protobuf, which is kind of nice. Support for pure WebSocket clients. So today when you build SignalR, you have a JavaScript client that we produce and you use it. And you kind of have to use the client. If you don't use the client, it's practically impossible to connect to a SignalR server, okay? And that requires you have a jQuery dependency and yada, yada, yada. In the new world, we want to make it possible to say, well, if I have a WebSocket, let's assume the best case scenario. I have a WebSocket. It's full duplex. It has framing. It has all these nice features that we want in a transport, okay? Let's assume that's the default. Why don't we build a system where I can just connect you with a WebSocket? And then as long as I speak the same protocol as the endpoint that you've connected to, that's all you should need, right? You don't need any other client code from us. So that's what we've done. If you want to speak in a different transport, if you want to use service-end events or long polling, then sure, you're going to need a small client library to emulate that connection for you, just like we had in SignalR of old. And then if you want to speak to hubs, you'll need a library that formats hub messages, okay? So that you can send hub invocations to the server and you can receive hub invocations from the server and maybe even send results back, which is also a new feature that we're looking at doing. So that's kind of nice. And we're going to use some of these features and some of the demos we have after these slides. So that's the next thing, returning results from client method invocations. One of the first things that people often ask when they program with SignalR is they type their code on the server that looks like it's invoking a method on the client, right? Clients.all.something or clients.thisClientID.call this method. And they want to get a result back. They expect to be able to get a result back from the client. We never supported that. But David just spent the last hour and a half hacking that feature into the new SignalR. It's something that we want to do. And we hadn't done it yet, and I thought, wouldn't it be great if we could demo that? Can you make that work?
Yeah.
And so we actually have, I think, something working that kind of demonstrates what that might look like.
Pretty bad.
It's terrible. But it's a very interesting idea. It effectively turns SignalR, rather than being a client-server technology, it's basically just a full duplex pipe, right? And it has two parties. And it might be that the server in your system has lots of different things connected to it, so it is logically the server. But from any given connections point of view, it's just two parties and they're calling each other back and forth. You're kind of doing RPC back and forth, right? Opens up some really interesting programming paradigms, especially when you consider async await on the server and async await in the client with TypeScript. You can just call a method in C# that's actually a TypeScript method in the client, await that, and then the client can do some work as a result of that method being invoked, block on some UI in the client, and then return a result back to the server, who's just sitting in an async, state machine waiting for the result from the client.
So you can block the entire server from blocking on the
So
client.
now you could deadlock your server.
That's pretty good.
By writing bad JavaScript.
We should do that.
Isn't that great?
Yeah.
We're not kidding. Right. So, as I said, TypeScript, so we've rewritten the client from scratch. It's a completely new JavaScript client, which is actually written in TypeScript. And I think the demo that you're going to show later, you actually wrote the code in TypeScript as well. So you get a lovely TypeScript experience when writing your client code, which is great. And then lastly, as I mentioned before, as a result of dropping our one model tries to suit all scale-out design, we have a much more flexible design for doing scale-out, which should allow you to either drop in pre-configured things that do scale-out in drastically different ways, or write your own scale-out that's really suited to your particular workload without you having to reinvent the world, which is kind of nice. So what does this look like? So in this basic sort of basic architecture for the low-level stuff, or ASP.NET Core sockets in general, right at the bottom you have a host. Okay, so everything else is host agnostic, really. So okay, someone is hosting you. All right. Then you have transports. Transports are things that know how to get bytes out of something, turn them into something that can be passed further up the stack. It's pretty straightforward. WebSockets is a transport, for example. You might have a TCP transport. Transports typically belong to a host. All right? So HTTP host of some description will speak various HTTP transports. All right? Now, in existing SignalR, we only had an HTTP host, and we only had HTTP transports. Okay? We had 4 of them. Then you have the gray arrows, which David convinced me, or didn't, but insisted was better than another block in there.
Yes.
That's the actual connection object. So we do have a type called a connection, and that effectively sits in between transports and endpoints, and that's what you program against inside your endpoint class. So then we have endpoints, which is what you program with if you're building a low-level thing. And then we have this other thing on the side that you can optionally use called formatters, which David's not quite sure about yet, but I like the idea of a lot. And so we're still having big debates about how far we'll go with this formatter thing. The idea is that they're effectively like serializers, but they understand the connection and they understand metadata from the connection. So a connection can say, hey, I've connected on this transport, and I'm going to pass you a string that says this is the protocol I want to talk. Okay? Independent of the transport type. And then somewhere else in the system, you can say, well, I'm going to register a formatter that understands this protocol name and can produce this T, right, this C# object. So that in your endpoint, you can just say, okay, I have a connection. I don't care what protocol it speaks. Just ask the system for a formatter that can read the T that I want. Right? So your endpoint code becomes very generic, just like control flow, reading your objects, writing out your objects. You don't have to worry about protocols and transports and those type of things. You just read and write Ts. Okay? And then all that logic to deal with bytes and how to turn a byte into this T and vice versa is all in the formatter system. And we have some examples of that, so we'll see that. And then on top of all that is the high-level API that if you've used SignalR, you typically would use is hubs. Okay? You just write hubs and all this other stuff's taken care of for you. So with something like SignalR, where it's let's plug in some 2 different hosts underneath. On the left-hand side, we have HTTP transport. So we have web host, which is the API in ASP.NET Core that boots ASP.NET Core and talks HTTP. And then on top of that, you have middleware, okay, that sits in the ASP.NET Core request pipeline. And there will be a middleware. It'll basically be the SignalR middleware, or the sockets middleware, I should say. And it will have a bunch of transports. And the 3 that we're going to support are WebSockets, service-end events, and long polling.
Where's the iframe?
The 4th one we have killed. We
took
it out the back and we beat it to death. iframe was an abomination.
Yep.
Right? It really was. That was probably one of the biggest bug farms
Tons of bugs.
And like no one uses IE anymore, so we're fine. They can use long polling. It's all good.
Yes.
It's all good. On the right-hand side, in an alternate stack in the same application, I can have a different host. So I have a TCP server that speaks with a TCP transport of some description, right? And then both sides of these both talk to the same hub endpoint. That hub endpoint code is agnostic to whoever is giving it bytes. It doesn't care, right? And so this way we can have a bunch of hubs that you write up in the top right-hand corner. That's generally where you'll live. And you can fire up a TCP server, fire up an ASP.NET Core server, or it can TCP Core server inside an ASP.NET Core server, which is kind of cool. And you can accept connections from different types of clients. And you can imagine extending this to various other types of transport. So we have examples of MQTT endpoints that speak MQTT, funnily enough. AMQP is another protocol that comes up. Or you can write your own custom protocols, which we have an example of here, which we'll do in a minute. Okay, it's time for demos.
Demos.
That's all the slides. All right. So I'm going to start out with a demo of, I hope works, because I'm using like physical hardware, so anything could go wrong. This is basically a board that has a Wi-Fi chip on it and then a bunch of resistors and capacitors. There's really not much else on it. It's basically a Wi-Fi board that runs Lua, as far as I know, right? And this was given to me by a guy on the SignalR team who's been playing around with this. And he's actually blogged about this last week. So if you look at this and go, I had that board at home. This looks amazing. Or I like the idea of this, then you'll be able to follow along. So I've just plugged it into my machine. And the way it works is it actually connects to Wi-Fi. So I'm going to open up the hotspot on my phone, because I can't get it to connect to the conference Wi-Fi, so I've been doing this through my phone. It's actually already on. And I'm going to open PuTTY down here, and I'm going to connect to this profile here. And so this is the name of a board. It's the ESP8266 node something board, something. And so I'm going to try and open it. And then I have a Lua initialization script, and then I have to hit the reset button for it to work, apparently. There we go. So it has a Lua script that runs on boot, which connects it to the Wi-Fi. And so you can see here it has a bunch of modules. It has WebSockets, it has Wi-Fi, and some other stuff. All right, so then what I'm going to do is I'm going to run a do file, and I have a socialweather.lua file that's already on this board. And if I've given it enough time to connect to the Wi-Fi, I'm literally talking over a COM port to this board right now. So I'm going to hit enter, and I'm going to hope that it connects to my server in Azure, because I have a server up running in Azure, which we'll see. It says it's connected, so that's good. That's a good start. So I have my app here running, so I'm going to connect another client. I have a C# client here, so we'll run that one. So that says it's connected as well, so that's a good start. And every time I resize this window, I regret it. Somewhere down here is my text. Nope, up here. Come on. No! I lost my text. Scroll, scroll. Is there a trick?
What'd you do?
I resized the window.
How dare you?
I'll Control F5 again and just live with it being big. How's about that? All right, so that's there. And then over here somewhere, I have the actual server app. So let's reboot that. All right, so I have my web app running up in Azure, and I have my Lua board connected over my phone's Wi-Fi, and then I have a C# app running in the console. And if I come up here and hit send report, if all goes well, they all update, which they did, which is great. Okay? Now, what's interesting here that you can't see is they're all speaking different protocols. All right? So the JavaScript in this page is speaking JSON. It's sending JSON back and forth. Okay? Pretty standard. If you've ever done SignalR, that's what it does. The C# app is actually using protobuf. All right? Anyone use protobuf in any of their stuff? Okay, a few hands, okay. So protobuf was protocol buffers was made by Google, and it's a binary format, very highly packed, very highly, all laid out nicely for running over the wire. And there's a C# library for it. And you basically define a shape of your thing like this, using a .proto file, and then it generates C# for you. Okay. So this program here is using protobuf, opening up a WebSocket connection. You can see down here, client WebSocket, and then speaking protobuf over that. And there's not much code, like it's pretty straightforward. And then when it gets a message from the server over here, it spits it out in the console. And then if I hit enter over here, it'll send. So I can hit enter and it sends one, and then I should see that one get updated over here, and I should see this one. I've got a second one down here. And so the last one, which is a Lua script, is speaking a custom protocol. It's actually a pipe delimited protocol that's just written into this application. And so I've got a little command here that I have to run. So I have to send over the active WebSocket. So I'll say WebSocket send, and then the pipe delimited protocol, I send the temperature in Fahrenheit. So I'll say it's 44 degrees. I don't know what it is. I don't know Fahrenheit. 2, which I think is the whether it's partly cloudy or sunny or something like that. 0, which is, I think I can't remember. It's something else. There's 4 fields. 1, 2, maybe it's the client. I can't remember. And the last one is the zip code, and I'll just use the Redmond zip code. Then I have to end that with a new line, and then I'll close that off. And so I'm just typing into my COM port down here. And then if I send that, that went up to the server, came back down to this client, and was also reported out over here in the protobuf client, and it was updated here in my page over here. Okay, so I've got 3 different clients using 3 different languages and 3 different protocols and 3 different connection techniques, all speaking to the same endpoint. So what does the endpoint code look like? Because that's really what it comes down to, is you want your endpoint to be fairly straightforward, right? So let's zoom this in a bit. All right, wait, I'm not that much. That's way too much. My control zoom's a little overzealous there. All right, so effectively I have my endpoint, derives from endpoint here. I get in this persistent connection lifetime manager thing. All this API is very much in progress. Yeah. Okay, so a lot of these types only exist in this sample, right? Because we're literally building apps, writing boilerplate, and then deciding what boilerplate we want to get rid of. Okay, so there's a lot of stuff spread out all over the place. But the concept of an endpoint is pretty solid. That's going to stick around. All right. We have this idea of a thing called a formatter resolver. This is a thing I will use to get the various, say when I want to read a T off the wire, please find the right format for that. And then a logger, so I can log stuff out. When someone connects to this endpoint, I get a connection object. I register it with the lifetime manager so I can track these connections. Pretty simple. Then I await process requests. And you can see this looks a lot like socket programming. You basically just sit in a loop and you read stuff off the socket. Okay, so if you've ever done TCP socket programming, this is pretty similar, except this, this is async. It's just a nice async await read loop, which makes it much, much nicer. So now that I'm in here on a certain connection, reading requests, I say, get me the formatter for the weather report, please, which is my C# type that I created, and pass in metadata from the connection so it can look up the right formatter, and then sit in the while loop and say, please read me off the current connection a message, which is a new low-level primitive. It's what you get off connections as a message. It has a buffer on it. And then I copy from that buffer into a memory stream, so I can pass that memory stream through to the formatter and have the formatter read the bytes in that stream and turn them into what I asked for, which was a weather report. So this is a little clunky right now. I'd like this to really sort of be like 2 lines of code rather than the 4 or 5 it is now, but you get the idea. And then finally, once I've read that, I can turn around and say to my lifetime manager, please send this weather report to all the other clients who are listening right now. Okay? Pretty straightforward. Really, really simple to do. None of the nasty parsing stuff is in here. This is just the basic control flow. This is kind of like your controller, right, in MVC. All the other stuff of like dealing with the input and output, like that would usually be a model binder or a formatter in MVC world. Very similar here. So my formatter for my weather report is here somewhere, up here, protobuf weather stream. So here's the one that speaks protobuf. So I have a formatter for weather report per protocol. So I got one for JSON, one for protobuf, and one for my custom pipe delimited one. So here it is here. Here's the custom one I wrote for pipe. It's kind of like a serializer, right? If you've ever written a serializer in .NET for a specific type and you serialize to XML or something else, or you serialize to JSON or something else, except these are all being sort of coordinated by a single thing called the formatter resolver. So yeah, that's kind of cool.
Awesome.
All right, so I know you've got some demos now as well,
of hacks.
some stuff that's probably going to work a lot worse.
Kind of
mine.
demos.
So if we switch over to the other machine, please.
All right, that was kind of cool. That was a fade. That was very nice.
Very nice.
Felt smooth.
Very professional.
I
thought it was your Mac.
I feel relaxed.
It's a
now.
Mac,
I
right?
feel
It
relaxed.
just fades in when everything else switches.
So this is the SignalR solution on its .NET Core as we speak right now. It's very experimental. There's tons of stuff on here that doesn't work.
In fact, when you cloned it in about 3 hours ago, wasn't it completely broken?
It's still kind of completely broken by smoke and mirrors. You can't tell. So I have a sample here called socket sample. It has a very basic setup for sockets and SignalR. Let's look at the start class of this thing. So I added, so ignore these for now. These are kind of, ignore those. I add sockets, which is the services required for .NET Core sockets. I add SignalR, and I can say I want to add these formatters, which are called invocation attached for some reason, but they're kind of still very much in flight. Ignore this stuff. This is just test projects.
I add some things that can...
You add some stuff that can talk protobuf or talk lines. And these are kind of a very SignalR-specific formatter for the invocations. So I guess this is kind of method name. This is a result.
Who's ever looked at the traffic in a SignalR app? Like you look at the JSON
It has
payloads,
like
the hubs.
M for method, A for args.
Yeah, M method, A for arg.
I for
this
ID.
is that, right?
It's kind of the same thing, but different
Decoding
formats.
Yeah.
Yeah, so there's an add Redis here that is commented out for scale up later that we'll show. There's a bunch of stuff added as services. I'll ignore it for now. And configure, there's a new app.useSignalR, which takes routes. And now you're mapping individual hubs to individual
Is that actual routes? It's a route builder?
Yes.
Nice.
So we actually use routing to map individual hubs to endpoints versus the old model where you had a /hubs by default. That was there for all hubs. That's a big change from before. The lower level API is use sockets, and you still map endpoints, but you still map the URLs, but you map endpoints, not hubs. So the way map hubs works is map hub actually calls map endpoint, and it maps the hub endpoint. So every single hub gets their own endpoint. So it's kind of a nice model for composing this kind of system. Let's run this sample and see what it does. Running using Casual directly, and I think I have logging turned on because logging is awesome. Let's see, there's a messaging sample and a SignalR sample. Messaging just has a raw endpoint that does kind of a chat, but with raw endpoints, and it has different transports. So I'll boot up all three, service and events. So it gets to fit on the screen. Nope, not today. Long polling here, and WebSockets.
It feels like 5 years ago.
Oh my gosh.
The same demo.
Memories. See, WebSockets is kind of broken. Oh, it works now. Perfect.
It works.
That's good. If I say hi, hey, nothing going up. Well,
WebSockets broke. Just refresh.
pretend this works. Like, just pretend everything is. Oh God. Did they like super break this? Debug on stage.
Oh, there's some stuff.
Oh, it said open, so that's like. Oh my gosh, it's completely busted. But just WebSockets. So everything else works. It's kind of nice. So hey, this is chat. Pretty basic sample. For hubs, there's the same thing. There's a clock sample that just pumps. Actually, I think I come to that one out. Let's skip that for now. Just do chat for now. Chat is working. Oh God.
That's a lot of buttons.
Does this work? Oh yes. Wonderful. WebSockets works fine.
Okay.
I can do this. Open up a new URL. Say transport long polling. Put these side by side. Connect this. That works. Can do one more. Do server sent events. Connect this. This is all boring, right? Because it's all just like.
It's all the stuff that always worked. So does the code look the same as before?
Let's look at the code.
Can we look at
the
the
code? Is
hub
a little
code?
bit different.
Then maybe the endpoint code?
It's a tad bit different.
Okay.
All right, so let's start off with endpoints. So I have an endpoints folder here with one endpoint called messages endpoint. And what it does, it has a connection list because I want to store all connections, so I can do a loop and then broadcast to each one. In previous SignalR, we had a bus, as Damian was saying. So broadcast really was like a publish to that bus, and that bus was pluggable. So if you're on Redis, it would do a publish through Redis. If you were on service bus. In this model, we want to be decoupled from bus altogether. So what we did was we made it feel more like a TCP. So when you joined, so when a connection gets bound to an endpoint, you can store a list of connections and then just do a for loop and call broadcast to each one.
Yeah, so the old SignalR was much more of a
It's very abstract.
pub-sub system at its heart. Like you dealt with it like pub-sub. This is much more akin to what we were really trying to go for originally, but we never did, which was just, it looks like I'm programming on sockets. I don't know who's feeding me the socket. I don't know if it's TCP or something else, but it's just a socket. And so this is really getting us closer to that. So in that world, this is stateful. Like this connection object, this endpoint I have, I'm going to get this connection per connection, and I can put them away on the server in memory in a connection list. And if I want to broadcast, I just go and for loop through them. Now, if you want to build a pub-sub system on top of that, you can, and we did that with hubs. Hubs is actually based on pub-sub, and that's what enables us to make it very easy to plug in other things. But at this layer, you just get a connection list as something you can, or you don't have to use if you don't want to. You just have an endpoint, you get a connection, and you write a while loop, and everything else is up to you. Yep. All the magic is in the transports underneath. If it came in on WebSockets, you don't know. If it came in on long polling, you don't know. We take care of all that in the transports. You just focus on writing your while loop, basically.
Yep. So the reason that sticky is important is because since you're stateful, you have to be on the same server for all connections. This list, if it was on one server and then you flip servers, you wouldn't get the same list of connections, and that wouldn't work at all. So
just like socket programming.
Exactly. So let's put a breakpoint and see how this whole thing works. Hit a 5. Let's do, this must work. Source and events. Loading. Very slowly. Then it connects today. Perfect. So whenever a connection comes in, the hosting layer tells the transport, hey, connection joined. It creates a connection, calls onConnect to async. And this code is supposed to run for as long as that connection is alive. So when this task returns, it means that the connection is dead. So in my endpoint, I store a list of connections for the endpoint itself. And then it broadcasts to all connections that someone has joined. All this does is it writes horrible, ugly code. You can ignore that buffer stuff for now. It does a for loop and does write async to each connection. The underlying API that we're using is a new API called Channels. It's in CoreFX Lab. If you've never heard of CoreFX Lab, it's kind of a playground for experimental features in .NET. Let me actually use.
Some of them are becoming very much less experimental.
Some are becoming real. Some are just there for fun. Yeah. So CoreFX Lab, .NET CoreFX Lab, there's a bunch of things on here that are kind of cool. One of the things that are on here is System.Threading.Channels, and this is what we build SignalR on top of, well, sockets on top of. What it basically is, does anyone use Go's channels? Go has channels. Anyone use Go?
Yep.
All right. Yeah, so you know what I'm talking about.
Basically that.
I mean, just think about it as a formalized way to do a publish and consume model. So you get a readable channel and a writable channel, and then once it does write, once it does read, and you can push objects back and forth between the producer and consumer. So the way this works in sockets is the endpoint is kind of the middleman. If you can actually, your slide kind of showed it. I think we can flip to your slide right now. Can we flip back to the?
Can we flip back to the other screen, please, Mr. Tech?
No.
No.
No. Almost.
Okay.
No. Okay.
No, that's all right.
That's fine. So the endpoint itself has the transport, and the transport has the.
Oh, there it is.
All right. So the endpoints have the transport, and the transports have the endpoints channel. So you have each side has one side of the others. So the transport is reading from the application and writing to the actual socket, and the application is reading from the transport and writing to the actual application. So
let's flip back to the other machine now, please. Thank you.
So when you do a write, you do transport, and there are different ways to consume the actual data. You can do write async, read async. Write async actually throws if the connection is gone. So to avoid that, I did a wait to write async and then try write. This pattern just lets you not throw exceptions for channel closes. So this code just says, I'm going to loop over every connection and then try to write to each one as it comes by. Does that. If write succeeds, it just breaks the loop and then keeps going. So a very simple loop. If I send data, hey, it does wait for read yields. I get the message back from the channel. And I put it in using because it's disposable, and I broadcast. So it's a very simple pattern. We remove the connection when it goes away. When the connection itself dies, so let's say I close this browser. If VS doesn't by design, it's supposed to kind of crash. The whole thing unwinds and is cleaned up normally. That's a very simple endpoint that we just showed, and this endpoint code works for any transport. So if I were to make a TCP transport or WebSockets, long polling, whatever transport, the same code works for all things. It's a transport's job to take the actual data from the underlying network and socket and turn it into a message object that's passed onto the actual transport connection. So to show you some code actually in SignalR itself, maybe the most simple code to show is like server-sent events. So in sockets, if we look at the dispatcher, and this code is all like crazy, so don't look too hard. When data comes in from the HTTP connection for a /send, we find the connection for the ID, and we just call wait to write async. So remember I told you that the transport itself has the application. So the transport says, I'm going to wait to write on the application, and then call try write on the application's channel. So that will yield the read async on the other side of the
We've got two sides.
connection.
I'm the transport. You're the application.
I call write.
Someone,
you call read.
Someone gave me a message.
Yep.
Because you've called read, and then I call write on you.
Yep.
And your read releases.
Release
get the thing,
get data.
and I go back to listening.
Yep.
The things over here.
And same for write.
And the other way around.
Yep.
We reverse it.
So if you look at the server-sent event transport, it's pretty simple. There's a while loop here that just says wait to read from the application. And whenever I read data, I just send it over the
There's a lot of
HTTP
while
response.
loops in socket programming.
While true,
All
like
while.
stay up forever. Yeah.
We need a loop primitive that just says loop.
Loop.
And
Loop
there's no exit or anything. You just have to throw or break. And
That
that's all
sounds
you do.
awful.
It's, while true is
Jeez.
like everywhere in this code.
Oh my
I guess that one's while await. That's not too bad.
Swallow it, yeah. Well, yeah, it's still while true-ish.
It's basically while true.
Yeah. All right, so that was.
But that's very simple. If you look at the code in SignalR that we had to write before async await,
Right.
and before we had this kind of socket layer, it was horrific. Like we had jumps, we had go-tos. I'm not kidding you. It was actually the easiest way to do an async loop.
I wrote the go-to.
You wrote the go-to. Like one night you just
that.
said, "Fuck it, I'll write a go-to."
That was awesome.
And
It was awesome.
It was the only way to make that code maintainable.
It was fast.
And it was very fast because there were no stack frames. It was always in the same stack frame. So
All right, so let's show something a little bit different. Let's show the TCP transport. So I have this endpoint, message endpoint, same endpoint that we had from before. I'm going to run it again, the server. And if you look closely at the logs, for those of you who saw it, this thing right here, starting TCP. Can you see it? There's a TCP service running in the application that starts on 5002. So there's a new feature in ASP.NET Core that isn't, in ASP.NET Core 2.0 that isn't really out yet.
in the future,
In the future.
that doesn't exist.
That will come out, called a hosted service. So we're trying to refactor ASP.NET Core to be a more non-HTTP based model, so you can host, your
other things,
TCP endpoints, your what's that?
It's basically a server host.
Yeah, a server host, a generic server host that can host any endpoints.
Any server. It could be background code. It could
background
be something
code.
that listens on a socket. It can be anything. Right?
So as part of that, we added a new API called iHosted Service. If you look at my startup class, if you add one of these things, you get called whenever we boot the application. We'll call start. Whenever we tear it down, you call stop. So it's a very simple interface. Like this actually does nothing, just to start and stop. What it lets you do is you have a place to write code now that kind of runs for non-HTTP things. So background things, like for example, this clock example. I inject an iHub context, which is very familiar if you've done SignalR before, where you can get the SignalR clients outside of the hub itself.
It's kind of like a singleton that subscribes to the lifetime
of the
events,
application. Yep.
But gets resolved immediately also somehow, right?
Yeah. So it's a very stable thing that tracks the connections, so you can actually broadcast to them on demand. So the clock service just is an iHosted service itself. And whenever start happens, I make a timer, and on tick, I just broadcast to all clients that are listening. And on stop, I dispose. So
and you have DI, so you just
and I can inject
the
services,
hub context that you want.
It's a very clean way to get services and do a non-HTTP thing in the same application space. On top of that, I just built this like 5 minutes ago. This TCP hosted service.
A Ghetto TCP host service.
TCP.
This is the one we're going to ship. This is ASP.NET TCP.
This is awesome.
Look at it. It's beautiful.
Let's push the code. All right, so what this thing does, it just takes an endpoint type, which is any endpoint type in your system, and it resolves it in the container, first thing it does. On a start, it creates a new TCP listener, and it runs this loop that just says, get connections, and whenever that happens, run. Don't do this very often unless you know what you're doing. Hands off. Awesome. Whenever a client comes in, it creates two connections, one for the transport, one for the application, same thing we spoke before. And then it makes a new connection object, calls the endpoint, the endpoints on connected async, gets the network stream, and then starts two tasks that say, I'm going to continually read from the application and write to the transport, and vice versa.
So this is effectively, it's full duplex, right?
Full duplex.
So I can be reading and writing at the same time, which is why there's always like two things.
Two things going at the same time.
Okay.
And then basically, this thing is trying to shut down gracefully in case anything dies. So if the read dies, kill the entire thing. If the write dies, kill the entire thing. If the app dies first, kill the entire thing. So very complex.
What's killing?
Yeah.
Yeah, that's socket
graceful
programming
killing.
for you.
And then the loop looks like this. I have write to transport. It basically takes a network stream, reads bytes off of it, 1K of bytes, and then it says, I'm going to call transport.write. And this will call the same code in the actual endpoint saying, I got data from some other transport, right? So what I should be able to do now is connect from WebSockets. Does this work yet? It's working now, perfect.
Don't touch it.
I'll open PuTTY, and then I'll launch this thing.
So now you've connected to a socket.
A socket.
Okay.
Like it's like here. And this works.
Oh, wow.
So this is data going over the socket, and it should print out, there you go. Socket service, TCP hosted service, 3 bytes came in from the connection.
So again, it's a single endpoint
Single
class.
endpoint.
You wrote one endpoint.
Same class, same state.
In middleware, and you mapped it to TCP.
Yep.
But it's one place where you write the code for the endpoint. Okay.
So it's the same instance, so the state is the same.
It's literally the same instance of the class.
Yeah. So the for loop is going over the TCP connection and the one from the browser and doing a broadcast. So unified API, same model, different.
So this is part of a bigger effort that was going on in ASP.NET Core sort of 2 and beyond, is that we want to take a lot of the primitives and ideas that we built for ASP.NET Core, logging, configuration, hosting, DI, pipelines for middleware configuration, all the patterns, options building, blah, 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 blah. We want to take all those things and wrap it up and use it outside of HTTP. Because we don't always speak HTTP, right? Especially in the world of Docker and containers and IoT and cloud, this and that, and PubSub and all that type of stuff. We want to take all that nice goodness that we did for building cloud applications and spread it out to other things. And this is the very, very early beginnings of this. Very, very early. Yep. But you can see the potential here.
So that was kind of cool. Okay, so hubs. Let's talk about hubs. So hubs are a little bit different, but just enough to annoy you. They're just enough to annoy you that they're different,
be, right?
But they're pretty close to what it used to be. We kind of got over dynamic. It was kind of cool, kind of gimmicky, and kind of nice to look at, but hard to look at, hard to debug, hard to get intelligence for. So we have this wonderful method called invoke async. We pass in a string, and it's not a string type at all, but it kind of gets the job done. We plan to have support for hub of T.
Do we not have that yet?
No, not yet.
Okay, we're going to have that though.
Yeah. So by default, today Hub gives you a client object, and clients.all, clients.group, clients.client, client. Whatever we have from before.
Groups,
I think.
all that stuff.
There's groups. Oh god, IntelliSense. That's a bug, you know. This is a bug.
Oh, because it waits on the next line?
Yeah.
Yeah.
Clients dot. So all there's client, there's group.
Just remember to move the code above
user.
when you're finished. It's fine.
Right.
There should be a fix-up for that. Move code one line above.
Nice. And this property is typed to whatever the T is here.
Right.
All right. So if I do Hub dynamic, in the future, you can get your old code back.
We actually had that in old SignalR, right? We added support for T of client hub.
Yes.
So we just haven't added it back.
Does anyone use that, by the way, in old SignalR? You can declare an interface, public interface,
My client.
client stuff. It's going to be hello. And you could say hub of client stuff.
Anyone ever use that in the old SignalR? SignalR 2?
Yeah.
Okay. So that will be the basis of the new SignalR. And instead of dynamic being the default, it'll be the string-based invocation. It'll be the default. All right?
Does anyone hate the string-based one and prefer dynamic?
I mean, so we'll support dynamic. You can pass in dynamic as the T. So you'll always be able to get back to that. So if you're porting an app and you don't want to change it, you'll just be able to derive from hub of dynamic.
So to put your code, just do hub of dynamic and be happy.
And then over time, you can get
and follow
the
bug.
dynamic.
Double close. Okay, so we call things async now. In SignalR v1, we had this aversion to calling things async. And I don't know why.
We were too opinionated about it.
We were kind of hardcore, but the whole thing's async. We can't call it async. Now we do because everyone else does. So, whatever. Invoke async is what it's called. Same API, so it looks pretty similar. So on connected, I'll invoke clients.all.invoke async, which does a broadcast. Connected, same idea. Blah left, blah joined, send to group, join group, different patterns.
And those methods are just ones on your hub.
Right.
So the clients are going to call those ones, right?
So
the other ones are overrides.
Yeah, exactly. So I'll run this again. Our build uses gulp, and it destroys the performance of the build.
This one does. We should make it incremental.
Look at this thing.
We should make it incremental.
It's the worst thing ever. Don't you use gulp? How do you do it?
Don't hook it into MS build.
Look at this thing. It's like 17 seconds. 17 seconds to do nothing. It's got this node. Oh, twice.
I'm starting to think it's not gulp, and it's just the way it's configured in this build script.
Are we holding it wrong?
We're probably holding it wrong.
Okay. All right, so here's a hub. I should put a breakpoint, shouldn't I? No, that's fine.
If you want to see anything.
Let's do that. Let's put a breakpoint. Okay, pro tip, the first one is always the correct one. Doesn't matter what it is. It's the first one in the list. If you have more than one, it's always the first one. I bet it's correct. Look at that.
It always is.
It always is.
I didn't believe you. And now I just do that every time rather than trying to look up the process ID and stuff. I just pick the first one, and it's always right. So.
Just trust me. All right, so I hit F5. The client went away. Connection left. Connect. Somebody joined. Very basic. I'll do a broadcast to everyone, which is just me again. Clients.all. I will send to a group. This is the worst UI ever.
It's the same as the really bad UI we wrote for the first SignalR.
Wait, so hold on.
We did.
I copied the code.
You literally took the same HTML.
This is the message, and I think this is the group name. So I shouldn't get anything now. Send to group. Wonderful. And to join a group, I say group, and I click the join to group button. This UI is pretty good. Join group.
You haven't got any better at doing UIs in 5 years, have you?
I know.
No.
I still suck. Now I'm in the group, so it works. It's pretty cool. So SignalR hasn't changed that much. A few tweaks. Groups.add, groups.remove. One big change we made, you can only add to groups inside the hub itself. Groups are super hard. So
yeah, groups was one of those areas we had a big bug farm in the old stuff. In fact, one of the biggest issues we still have is, in the old world, groups was async. Because when you added to a group or removed from a group, it sent a message through the bus so that you could add a client that was on a different server to a group or remove them from a group.
Right.
But that required that they get a message and send an ACK. And that meant that a lot of people would await groups, like you're doing here actually, and it would hang.
because you want to await group.add and then send to the group
And then send to the
to make
group
sure you're
so
in the
you
group.
know
Right?
that they get that message, right?
If you have two servers and a client over here, and you do groups.add on that client over there, and the server goes down,
Or the
and you
client
await
goes away.
and you await the group.add, you never get like
You'll get a
response.
30-second timeout, but
So we time out, and it was like a bug farm. So there you go.
yeah. I mean, even more, it just wasn't what people expected.
Yeah.
I think too. So we got rid of that for now. We'll see how people react to it, but
React. Nothing? They don't care.
good.
We're fine. All right, so other sample. iClock service, you guys saw this before. It does a tick every second and prints out ticks. So same application. Background service. Here's a clock and different like long polling. Well, long polling just because. Why not?
Because?
Why not? Connector.
Is this still hubs? We're still in hubs.
Still in hubs,
Okay.
but from a background service. So the clock service is broadcasting every second the ticks to all the clients. It's in sync. Yeah, that's pretty basic.
In the old world, to do that, you had to call a static API.
Yep. Global host.get.
Global
Global host is dead. We have DI now, so use DI to do things correctly.
Yep. So now you just take.
We basically hate statics. So if you use statics, you're not going to like us anymore. We just got rid of them. You can't test. It's too hard to test.
You don't need statics anymore in ASP.NET
Yeah.
4, though, so it's fine.
All right. So should we show the
We got scale out.
the crazy one? Oh, scale out. Okay.
The
Perfect.
insane demo to try.
Okay. So Redis. Let's do Redis.
Let's do Redis.
So I'm gonna do this magic line.
Anyone use Redis today with SignalR for scale out?
Just like
1,
before.
2.
Add Redis.
Anyone use something else for scale out with SignalR?
SQL Server.
SQL Server? Yep. Service Bus in Azure? No one? Okay.
Service Bus v3.
Everyone else isn't scaling out. They just run one server. Doesn't use SignalR. They're just here to take a nap. That's right. Okay, cool.
Okay. Let's see what I can do. So Redis via Chocolatey, because it's the best thing ever. Redis server. Run the server. Redis CLI. Let's monitor what's happening. Launch the application. Is it running? Kill it. Boot this up. Cross my fingers.
Building.
Gulp!
You could have commented that stuff out for the purposes of the demo.
By the way, we use TypeScript, which is beautiful.
It is beautiful.
It's wonderful. It has async away. It is like the best thing ever.
Who's using
If
TypeScript?
you're doing client-side code,
Who's not
you're
using TypeScript yet, but thinks they probably should at some point? Okay, good. You really,
Like, you need to do
really
it.
should.
I was an
lovely.
anti-TypeScripter, and then I converted.
As was I. Now I am a full convert.
All right, so let's look at the monitor, because that shows the actual what's happening. Oh, the clock. The clock.
Clock is destroying the monitor. You could turn it off.
Let me click the clock. The clock
Turn
is
it off and reboot.
clock is
Yeah.
annoying. Then gulp run again. Dead air, dead time. TypeScript.
Is this the good
Yeah, very nice. Async away.
Yeah.
Oh,
Oh,
not
you
here.
didn't use it because it broke, didn't it?
Somewhere else, yeah.
Tried to use it. Yeah. It's in the client.
It's in the client. It's
Yeah,
all
client.
over the client. So
Yeah.
we use async await like everywhere. If I can find it somewhere. There it is. Async start. Oh my gosh. Prepared. Okay,
Gold
perfect.
finished.
There we are, Redis. There's a bunch of bug sleeve stuff happening. Here we are again. So,
So
client,
what's
client,
going on here?
Let's see. Okay, clock is dead. Perfect.
Good.
Okay, let's open up hubs. Connect. So a client connects, and we subscribe to, in Redis itself, we subscribe to the individual signals for that specific connection.
So this is the big difference from last time, right? So now
Yeah.
the server has one connection to Redis, which is the same as last time, but it has multiple subscriptions which
Open to
are
Redis.
dynamic.
Right.
Multiple subscriptions to Redis, to PubSub, which are dynamic based on the connections that connect, right? And the signals that come up. So like
Right.
the hub is a signal, so sockets sample.hubs.chat. Any groups, any connection IDs, they're all different signals.
There we are.
And we basically dynamically
ID.
create and destroy subscriptions to Redis on the fly so that any given server is only subscribing to the messages that it has clients that care about. That's the big change from prior versions.
And this is kind of one implementation. We had one where we had a Redis connection for every connection on the client, which is kind of insane, but apparently it does.
It works. Apparently.
In some cases, yeah.
Yeah. But this is one connection, multiple subscriptions. You could do a connection per client, which we did do, and it worked, but we think this is a little nicer.
So if I do a send, broadcast, blah, publish via Redis, if I disconnect the client, unsubscribe from the actual things. And the way that works is we have a new abstraction in SignalR called, it's a bad name. It's a
temporary name. We'll come up with a better name.
Hub Lifetime Manager. And what this basically does, it gives you full control of the entire lifecycle of the hub. So anytime someone joins a hub, anytime someone disconnects from a hub, anytime someone invokes anything from a hub, it goes through this abstraction.
Basically, when you're in the hub, clients.anything, on anything, anything goes through this thing. Right? And so you can just replace this thing and take over complete control of how hubs send their messages. This is how you do scale out now. Right?
So by default,
get in under the covers.
By default, the default implementation, as an example, has a list of connections. And
the in-memory one, you mean?
Yep. And when someone joins, we just add to a list. When someone removes, we remove from the list. For a broadcast, we do a for loop over all connections that are currently on that server, and we
just call
send to each one of them. That's kind of a very basic implementation. You could have one that used the old model where you had a bus. So the whole idea is that you can implement different kinds of abstractions based on what you think is best for your hub implementation.
And this is all at the hub layer. Previously, this underpinned all of SignalR.
Right.
But the sockets layer, as you said, we're really trying to go for just a pure socket-like abstraction, which has transports that are pluggable. But we're not opinionated about this type of thing. Like you would, if you want to do this at the endpoint layer, you would just create another type, take that into your endpoint, and just funnel everything through it yourself. That's what the hub endpoint does. The hub endpoint literally has one of these, whatever one was registered, creates it and funnels everything through it, and does all the hub discovery, and that's basically the hub endpoint.
Didn't you write a quasi-scale that was like SQL and
so I wrote a different scale-out provider that used SQL Server to store a table of active connections, so you could actually query the database and say, just give me all the connections that there are right now, give me their usernames, give me all the signals there that they're interested in, and then it connected to Redis to actually do the sending of messages. Right? So it was a stateful scale-out system where state was in a persistent thing and all the messages went through Redis. So it's a super flexible now, and there's not a lot of code. Like the default one is a couple hundred lines. The Redis one is probably less than a couple hundred lines.
Redis is pretty simple.
Super simple. Whereas the old message bus system was horribly complex.
Super insane.
And went through many, many iterations to try and make it better and less bug prone.
And it's still buggy.
I mean, it works fine. The scale-out one in particular was particularly complicated.
Tough.
Yeah.
Okay.
Couple hundred lines.
So
a few hundred lines.
This is Redis. Does a bunch of stuff. As an example of what groups do, whenever you join a group in Redis, it adds a subscription to that connection in Redis. So if we look at the thing here, and I join a group, let's see, join group foo. Did I disconnect? Let me connect first. Join group, subscribe to socket sample chat group foo, and I can broadcast to that group. Send to group, it goes to Redis with a publish. So you have full control of the entire life cycle of connects, disconnects, sends, receives, the entire thing. We want to enable you to actually round trip data to the client in case you want to round trip cursors. If you want to implement your own semantics for reconnect, and you can round trip the last cursor you saw for messages, you can also get the entire cycle in the lifetime
management. You could effectively get back to the old SignalR behavior.
Yeah.
Because we're going to add enough hooks for you to do that. So I won't say reliable messaging, but you can do reliable messaging. Okay, so you've got one last thing in a minute and a half.
Uber demo. Okay, so
60 seconds.
This demo makes no sense, but let's just do it anyway.
So I remember I said that what we wanted to enable was the ability to, when you invoke a method in a client, you could get a result back. All right? Which is kind of crazy. You're on the server, I invoke some browser, and I get a result back. We hacked something to go, Fowler, hack something
Imagine
together.
You want to use an image library because there isn't one on .NET Core, and you want to invoke JavaScript
in a browser
and send the image back. It's kind of ridiculous. Would that
Not
work?
Image Magic, yeah. Why would you want to use that? Just use what's in the browser.
We should try that.
So actually, when we first built SignalR, Phil Hack, the first app he wrote was, how do I get stuff back from the client? I'm trying to build a game, and I want the server to say, ask a question from all the clients, and just sit there and wait until the clients answer.
Phil, you're crazy.
And we thought he was crazy, and now 5 years later, we're building it. So finally.
Okay, so Phil was right.
Phil was right. This is actually pretty cool.
So let's put a breakpoint here. So the game needs two players. Let's connect 2 clients. The first one always wins. Yep, perfect.
All right.
2 browsers. Okay. Game, disable button, disabled there. Game here. All right, the button should become enabled at some point. So
there's your breakpoint.
It's going to start the game. So it invokes on all clients in the game so far the ask question task. And it does a when any, saying that when any of those tasks yield, someone won. All right, so the first to click the button wins the game. So since I'm doing it myself, this is going to be super dumb. But if I'm fast enough, I can win. So I click me, and the task, it did yield. But that actually, that await was like waiting on the client to respond.
It's asynchronous, but it's actually sitting there
Like,
waiting for him to click the button.
This should blow your mind. It was waiting on the client to respond. So the client responded with a click button, and then it yielded the task on the server. And we get a result back, and somebody won. Connection 917, congratulations, you win the prize, right? And then if I hit a 5, you win. There you go.
And the other one,
lose. All right.
And that's it. Can we flip back to this machine, please, just for the end here? I've got one more slide. All right, so the timeline for this is, as you can probably tell, this is in development right now.
What?
We hope to preview this about mid this year, and with a goal to release it by the end of the year. So ASP.NET 2.0 is currently slated for around the middle of the year. That's what we're targeting. This will not release at RTM at the same time. There's just too much work to do. And it's being underpinned by a whole bunch of stuff in FX Labs, which just isn't ready yet. But we're hoping that by the end of the year, SignalR on core and the stuff underneath it will be ready. If you want to track along with the madness as it is right now, while we still figure all this stuff out, you can do that on GitHub. We're active development. There's a team of like 4 people working on this every day right now at /ASP.NET/SignalR. So thanks very much for coming and putting up with the craziness that is a work-in-progress project. But yeah, this is the last talk, and we'll see you all guys next year. So thanks.